So we went over pretty much everything we're going to do today. I only had one new thing. So most of this is a review. Again, I get that doesn't mean you know how to do all of it. Although if you've been putting a little work into it outside of class, I don't think it should be horrible. Yes, sir. This was the bell work. Yeah. So, but this bell work is kind of also like a review as well. It's a lot longer bell work, only long, but it is all review stuff. We've done everything in this. So we talked about a ratio. Ratio, we said, if you weren't here, has to do with comparing like typically two different things. It could theoretically be more. So if I, for example, had some marbles, we said, and I had 5 blue marbles and 3 green marbles, we said the ratio of blue to green in that situation is 5-3. Now you'd have to be told that the 5 was the blue. I'd have to say blue to green. Now in a line segment, you typically just, and there are some exceptions to this, but we're not going to worry about exceptions. Hopefully they don't throw a bunch of exceptions on the EMC or the district stuff. Normally, the first number is like how long is the left segment. The second number is how long is the right segment. Typically, they could reverse that by giving you like the names of the points or something. I forgot to put this in. So that was A and that was B, by the way, if you were trying to do that one. So again, you need to know this. Write it down if you didn't write it. If you didn't write it. The first number, they always represent the length of the segment. Like we're trying to put a point on a line, and this number tells us, well, when we put that point, the left segment better be longer than the right segment. Because it's the length of the ratio is 5-3. 5 tells us it's a longer segment when we're talking about ratios. So ratios have to do with length when we talk about line segments. And specifically, it's telling us this line segment should be bigger than that one. And the greater the difference between the two, the longer it would be relative to the other segment. Like 4-1 would be a 4 and a 1. Well, that's 4 is 4 times bigger than 1, so it's going to be quite a bit bigger in that case. So like when we do this 4-1, that would be, we can even estimate if we had so on the quiz, there's a question where I don't give you any numbers. I just kind of say, hey, if the ratio is this, where do you think the point would be? No numbers or anything. I give you the ratio, but no value from the number. So you just have to say, well, 4-1, I know the middle would be here. Would I go right or left from the middle? The ratio is 4-1. Here in both. So again, it's not weights. You got to make sure you keep weights and ratios separate. This has to do with the lengths of the line, not a point being heavier. There's nothing in that that says anything about weights. And we are going to kind of use weights later to solve ratio problems. So you got to keep in your head what they mean, as well as the way to do a process using weights and ratios. This means length. When we finish that, so did we come to a good rate? Actually, let's do this. If you don't know, still raise your hand. Guess. Raise your hand if you think. So the middle would be somewhere here, right? That's definitely not right. One segment's got to be quite a bit longer than the other. Raise your hand if you think we go left from the middle. Raise your hand if you think we go right from the middle. All right, good. So this represents the length of the left. That represents to the right. Or we really said, this means you're going to have 4 smaller segments on the left after we split it up and figure it out, and only 1 on the right, which means, yeah, it's got to be way down here. Somehow I got to have 4 of those sections over there and only 1 on the right. So you would go to the right. Good. All right. How many total sections would I have then? That was actually the question. 5, right? We got to just have it. I would have 4 on the left. That's what that number tells us. 1 on the right. So the total would have to be 5. That's the number we use to then divide it into segments, which we'll do in a second. Any questions on that problem? What about weights? What was the big important concept on weights we said? What is the weight of a point or can it do if it's like they're not weighted the same? If they're well, let's try that. If they're weighted the same, where's the average going to be? Right in the middle, right? What if one of them all of a sudden becomes a lot heavier? What's going to happen? Yeah, that heavier point pulls what I call the normal average. The heavier point pulls the average in that way. All right. And then when it comes to actually solving, what's our process? So I'm going to give you the process really fast. I did a couple of videos where I went over this a lot slower, and I said step one is this. This is for doing a weighted average. Step two is this. Step three is this. We've done it in class, but I didn't really emphasize here's step one, here's step two, here's step three. So I did that in a video. When I practiced, I think it's a problem or something like that. What's first step? I always start with it. What's first step? Meeny, miny, mo. Sorry, what's first step? We're going to do it using weighted average. I want to solve this problem where it says weight of A is 2, weight of B is 3. What's first step? If you don't have these steps written down, like step one is this. This is the time to do it. We're giving each other the steps right here. I don't care if she helps you. So I'm going to combine it all. We need the weights will come from the question. There's no other way you would know the weights. Like they have to come from the question. They have to tell you the weights. So once we find the weights, step one is to just write the weights over the point. And again, it tells you exactly what the weights are in any problem. Don't worry about the as much as. What follows that? That's not normally important. If you're struggling, I mean, you get what that means, fantastic. But if you're really struggling to pick the weights out of the problem, it tells you all right where the weight or the point itself is. Weight of A is 2. Even if it says A is weighted 2 times as much, it's still the weight is right after the A, 2 times or twice. So it's always right around where the letter for the point is. So weight of A is 2, weight of B is 3. It's pretty straightforward. So weight of A is 2, weight of B is 3. All right, that was step one. Find the weights and write the weights above or below the point or next to the point, whatever you want to call it. What is step two, Kiki? Once I have the weights, what do? It wasn't math, it was drawing. Sort of. You don't know, I'm just going to skip you. We're just getting the steps out. Ayana, what was step two? Draw the circle. Why do we draw the circle? That tells us to what? It kind of tells us which math we need to do. It helps us remember which math to do. So we do what? Multiply. So you can write, if you just want to write multiply because you got it down, that's fine. If you don't have it down, talk about memorizing the steps. Step two, I would write circle with, and I don't have all this. Oh yeah, I do have the steps on here. Yeah. The steps are on this thing. I took a picture of it. Steps are on here. But again, I'd still write them down next to an example because there's not an example on that worked out. But it tells you step two is circle, which tells you to multiply. So we're going to multiply those two numbers. 2 times 5 is 10. 3 times 25 is 75. Step, we're going to leave off. So Keo, what is the next step? Step 3. Man, I kind of already gave you step 3. You get it easy. I already wrote it. I add together. So step 3 is once you've multiplied and you got that and that, I add them together. So I kind of gave you step 3. Again, I'm not writing step 1, step 2, step 3. They are on the sheet, but you need to have a problem worked out with those steps next to it. And then last step, Christian, what's the last step? So I divide by these, I said sum of the weights, but if you're confused by what that means, you just divide by all the weights added together. That weight was 2, that weight was 3. So I divided by the weights added together. And that's your answer. Like you're done. It's not like ratios where you got to figure out, okay, well, how now that I've done all my math, how many sections are on the left, how many sections are on the right? That's your answer in weighted average. You're done. So if we do that, we get 85. I'll write over here. Divide by the weights added together. So if I divide that out, we get 17, I believe. 17. So I'm going to erase that middle. Anybody writing the middle part? If I'm recording, so if you didn't get it, you can go back and get it. So 17. So again, what would the midpoint be in that? If 5 and 25 are my endpoints, what's the midpoint? 17, 15, right? 15 would be right in the middle. It's 10 away from 5, it's 10 away from 25. Well, 3 is obviously heavier than 2, it's bigger than 2. So 17 makes sense. It makes sense that we would be a little bit right of the middle because we have a heavier point on the right. So again, always think about that at the end. And if you happen to make a math error, you might save yourself from this question if you make sure that that point landed about where you think it should land. All right, any questions? Really all review stuff there. If you're not, if you were totally lost on all of that, you got some work to do tonight. You want to do well tomorrow. So that's the stuff you should know. This was pretty new. I can understand that being not as fresh, but all that weight stuff you should know. We spent quite a bit of time on it. All right. No. I did not really get to doing a difficult midpoint problem. It's not on my quiz, but I believe there is something on the never find that stupid blah blah blah. Oh, maybe I did. All right, so here's my first question. How long is that first line segment? Top line segment. It's just 2, right? I exaggerated the endpoints because I still have people not understanding that the length doesn't just come from one of the numbers. What do we have to do? We subtract. Remember, a lot of people are adding them together or they're like just looking at the right number. So that's why I started at 100 to show you there's no way the length of that little tiny line is going to be 100 or 102 or 202 or whatever. Some kids were doing that yesterday. You have to understand length to subtraction. Again, I put some big concepts on. That's one of them. Length to subtraction. So here's what I want you to do. You have 2 problems. I want 50. That's, I guess it's a different page. So with that in mind, I want you to do these 2 problems. I guess I have 2 copies of that same slide. Which is fine. I want you to do those 2 problems. So when it says split, that means put a point on the line or locate a point on the line that will split it into a ratio of 1 to 2. And then you know how to do weighted averages. 1 to 1. I'll give you 3 minutes. Should be good on that. I'm going to set a timer for the rest of class. Which would be what today? 9:02. Yeah, work together on these. If you're sitting there lost, you need to find a very helpful neighbor. I mean, I'll walk around and help too, but obviously I can't be everywhere at once if people need help. So for that 23, 24, 25. We win Friday?
No, we didn't. No, we've gone. 3 points.
Are you comfortable on this stuff? They didn't provide enough cheer. They didn't provide enough. I had one out here. All right, so we'll use this one. Christian, you ask me, Christian? I'm doing leaving home, so trade me a phone for that. I saw your phone. It's on the card. All right.
My answer's right.
I'll give you another minute. Didn't take you long. These are pretty easy problems. If you're struggling on these, you got some work to do tonight. There are IXLs for partitioning a segment, so think about what you think your answer should be before you even answer it, and that.
No, wait.
Well, the bottom, the blue one is a weighted average function. I got. Yeah, there's two problems. So there's two problems up there. You're doing the black line, the blue line. It's two different problems. Sort of. Kind of, sort of. That's the first time I've ever heard anybody like tutoring.
There's no way.
All right, so I'm going to go ahead and start moving forward. If you're making progress, that's all I'm really looking for. Remember, I'm recording this. There's a point that I'm trying to make with this, and then you'll have a little more time to do the next one. So what do we do in that first problem? We're splitting it, right? Where did I leave off? I think Omar's up, right? Omar, the main man, Omar. What position is he? Kicker. Scoring points. Nice. All right. What do I do? I need to split the segment. What's the important part of this? What are they giving me? Or what are they not giving me? Either way. Now they're not giving me weights, right? This is not a weights problem. They gave me a ratio. So that means these numbers are about the length of the segments that I'll wind up with. I'll still only have two segments for my final answer. But in the process, I'll create more than two to figure out where the point goes. But my final answer is 1 point on the line, which just creates two smaller segments. Now, to get there, though, what do I have to do? I have to split the line into what? Dixie. Nope. Dixie doesn't know. I'll come up in front. Awesome. What do we do? I need, 3 segments, right? This tells me I'm going to need to have one segment on the left of the point that I put and two smaller segments on the right. Again, ratios have to do. If you didn't write this down, write it down. I'm going to show you something after this. It's going to be confusing if you don't understand. Ratios are about length. Weights are about importance. So I need to so let's just think about where it would go. If I'm going to do this and I'm going to kind of have one on the left and two on the right, they all have to be the same length once I've split them up. Where would you say? Like, am I good here? Do I go left or right, do you think? Actually, now let's call on somebody. Jordan, do I go left or right from here? If I want a ratio of 1 to 2. So you think here. So somewhere around there. Does that look like it's a ratio of 1 to 2? Left side should be 1, the right side should be 2. This side should not be bigger. It's like having one little segment here and two little segments on the right. So again, once you put your point down, it's a little easier to see. So instead of struggling with it, just take a guess, put a point down and say, well, wait a minute, that doesn't make sense. The right side should be bigger than the left side after you put your point. So sometimes it's just easier to put a point down. So let's put a point over here. Does that look like maybe that's a one segment and then, maybe it should be a little tiny bit to the right, but somewhere in this area, I feel like should certainly be the value, somewhere in there. So make sure you understand that because there's a conceptual question on there about ratios with no values. I just give you a ratio and you have to kind of estimate where it goes, not knowing any numbers. All right, so we've already said we need to split it into 3 smaller segments, and then we'll make one smaller segment on the left, 2 on the right. So, yes. Because we're going to eventually want 1 on the left, 2 on the right, which means we add 1 plus 2. Correct. That tells you. So the shortcut version is, if you want to know how many segments you need to split it into, you just add those 2 numbers. It'll make more sense visually. Malachi. How do we split it into 3 equal segments? What do we need? Well, we'll put the points on there, but how do we get to the 3 equal segments? What's the next step, basically? If I know I want 3 equal segments, what do I need to do? What do we do when we divided basketballs and volleyballs and baseballs up into groups? What do we do? Philip just said the answer. That's it, dividing. Yeah, we need to divide. You need to take the length of the entire segment, which we just said is subtraction. So what's the length of that? 27 subtract 3, so 24. Take the length of the entire section. If you don't know this, you need to write it down. Divide it by how many segments we want, which comes from adding these two together. So if I do that, my answer is, what's that 8 stand for? What did I leave off? Sebastian. What's the 8? Not exactly. You might understand it, but I'll explain it a different way. I'll give one more shot. Do you understand exactly how to explain that? What's that 8 stand for? Anybody else? What's the 8 stand for? Perfect. So I'll say that again out loud. The 8, just like when we divided the different basketballs, footballs, whatever into groups, when we divided it by how many groups, the answer was how many in each group. This answer, we don't have a how many in each group. We have if this is the length of the total segment, this is the length of the smaller segment. So that is how long each smaller segment is going to be. So that's what I use to divide up into 3. I add 8 to that. Somewhere maybe around there is 11. I add 8 to that. Let's erase this. And if I add 8 to that, maybe somewhere around in there is going to be 19. And then you better land exactly on the endpoint or you did something wrong. Every segment has to be the exact same length. So this one is 8, 8, and 8. And now the last part is, well, they want me to put a point on the line that will split it into a ratio of 1 smaller segment on the left and 2 smaller segments on the right. So what value would that be? Where did I leave off? Janelle, what value would that be up there? 3, 11, 19, 27. Want 1 on the left, 2 on the right. So again, that is a segment, that is a segment, that is a segment. I want 1 segment on the left, 2 on the right. Sure? Kayla, nope. Adeline, where'd he go?
Oh, on the first one.
Yeah, it'll be on the left. So again, if I put my point right there, I have 1 segment on the left at that point. So again, if you didn't know how to do that, and I'm guarantee you, it was a lot of people that didn't know how to do it. 1 segment is on the left. That's this green. I'm going to change colors. I have 1 segment on the left and 2 segments on the right. That's really what the ratio means. We say it's the length, but technically the reason it's longer is because you have 2 of the smaller segments on the right. So it's twice as long as it seems. How do we get 24? The length. We wanted the total length of the line segment, and we said length is subtraction. So you got to take the total length and divide it by how many segments you want to find out how long each little segment is. All right. I'm going to do this next one really fast, but raise your hand if you did it and you were like, yeah, I know I got the right answer. Like, I remember how to do weights. I'm going to call on Jason. What'd you get for your answer, Jason? Got 11, right? Isn't that a coincidence that we got 11 up here, but we got 11 also down here? And isn't it kind of funny that, what were your weights? Isn't it kind of funny that we have the exact same numbers, for our weights, just kind of reversed, right? So up there, the 2 was on the right, the 1 was on the left. Down here, the 2 was on the left, the 1 was on the right. Not a coincidence. Weights are the opposite of ratio. The weight pulls the point toward this, right? So it'll pull the point that way. The ratio is about length, so it meant that side had to be longer, but it's the same thing. You're dividing a line up based on really based on a ratio. Even the weights are ratios. Or you could say even the ratios are weights. So I'm going to tell you right now, you can do every ratio problem just like a weight problem with one adjustment. What do you need to do? You think? What did I do? That was the ratio 1, 2. What did I do to create weights? I'm low. Flip it. That's it. If you just take the ratio they give you and you reverse it and you make the left number the right number and the right number the left number, do every ratio problem. Well, I shouldn't say every. They intentionally give you some kind of a trick in the problem. They could create something where it wouldn't work, but I'm not going to teach to the little rare exceptions. If you understand it and you understand how weights work, you'd catch that mistake. If you understand that weights pull it in a direction or that ratios, we're talking about the length of the 2 smaller segments. I don't think even the state would do that on one of their quizzes. So again, let's talk about this because this is the key and you got to understand. So I'm going to go into this next one. You just have to make sure you understand when the problem is a ratio problem versus when the problem is a weights problem. And the clear line is they talk about weights. If they don't talk about weights and they give you something that's got that little colon in it, that's a ratio problem. That's when you would have to switch the numbers if you wanted to do it this way. Now, your question is more about just doing it as a ratio problem. If you're going to do it as a ratio problem, you don't do anything I'm talking about. Don't then try to bring weights in it because that's what kids do every year. They try to like mix them together. It's either or. I would just pick one way and do them all one way. Either always flip the ratio and do it weights, or make sure you're good on how to do it the ratio way and then just do the weights one the weights way. So if you're going to do it the ratio way, you have to do what you're saying. You don't do anything with weights, right? You're going to stick with splitting it into 3 sections, adding, then figuring out, well, I need 1 on the left, 2 on the right. We don't bring any weights into it, like multiply that whole circle and all that stuff. What was the way? Well, no.
Yeah, just
Well, that shouldn't give you the right answer. Did you get 11? Yeah, so 19 is not the right answer. So you did it. So again, you can do it. So here's your adjustment of that. Because you can do it with weights, but you have to, that's what we're doing down here. You flip, if you want to do a ratio problem. So again, I'll say it one more time. This will save you a lot of heartache. But if you want to do a ratio problem using weights, which we spent more time on, and that's why I spent more time on it. Definitely when you do a coordinate plane, this is a lot easier. Like I would say everybody's going to want to do a problem on a coordinate plane using weights. Oh, I didn't get to that last class. We'll have to get to it this class. I can record it. I can do a rate. So again, that is a ratio. They gave me a ratio. But I can do that using weights if I just flip the ratio, flip the numbers. The first number becomes the second weight or the right weight. The second number becomes the left weight. And you'll see we get the same exact answer we got up there, 11. So I'm going to do it now. So again, I'll just review weights. I already did the first step for you. I wrote the weight down. That was first step. Second, we're going to leave off. So Isabella, what's the next step? Circle, which tells me to do what? What math? So I multiply. 2 times 3 is 6. I'm going to kind of skip steps. and do some of them for you. Then 1 times 27, I need to add those together. What's the last step? What I leave off? Emily, what's the last step? By the weights added together, right? So 1 plus 2, so I divide by 3. So 33 divided by 3. And you see, I get the exact same answer. They are opposites of each other. That is way easier to do it the weights way than the ratio way if you have a problem that's on a coordinate plane. Actually, I did do that. I don't remember exactly, but they're pretty much the same. Now, on my test, the district stuff, I'll tell you, is more complex, and I have no idea what it's like with the state EOC. My stuff is pretty much exactly like this. There is one trick that you can do, which I definitely don't do. I don't remember if the district does something like it or not. I'm going to give you the chance to practice one on a coordinate plane. You should already have a picture of all of that. We'll go over in a minute. But go ahead and do this. So I'm giving you a ratio. I'm going to go ahead and give you the coordinates so you don't have to worry about it. So the rate, write this down because it's going to go off the screen. I want you to split this line into a ratio of 3 to 5. Again, you can do it using weights. There's just that. What's the one trick if you want to do it using weights? The 3 would wind up being the right weight. The 5 would be the left weight. I'll just go ahead and tell you what actually, that should be fine there. So your point A is 1, 2. Your B, I think it was A and B, is what's that, 9, 6. And it told you to do a ratio of 3 to 5. But and like I said, trying to divide a line into 8 parts when it's diagonal is tough. That's why I say weights is a lot easier on these coordinates. It's possible you can do it. Actually, this one's not even as bad as it can be. Do that, but if you can figure out how to do it, you can go ahead and do it that way if you really want to, using like dividing it into 8 parts. But sometimes it's going to be even tougher to do that than this one, and I would just say don't ever do it. Just use the weights. Well, I would do it using the weights method. That's the only thing we got to change. You do the weights method. That you're bringing to a totally different lesson. You're doing like slope or something like that. Yeah, go back to your weights process. I'll give you a couple of minutes, and then we'll have a couple minutes to go over it. That's all we're gonna have time for in class. I'll show you some videos I posted there where I did other stuff in it for tomorrow. Like that? That's okay. Yeah, you can always put with people here. I want you to do that. That's fine.
Like I said,
So I'm going to kind of get you started if you're struggling. That's the first step. You just flip the ratio. Now you just do it like we did all those other weighted averages. There's no y, subtract 1, any of that stuff. Oh, yeah. I got 5. So then I'm going to go over it. But I mean, if you have a question, if you move forward. And you're going to type it again, but you come to
yes.
And that's what you decide.
If you need to draw this out sometimes, like I would encourage you to just draw a quick graph. You don't need to draw the whole graph. Just draw a line and, put the coordinate next to the line. You don't necessarily need the whole graph. They don't give you the line, especially.
One of my friends, nothing like
There should be two numbers. You gotta do it with that extra. Let's go ahead and start working through it, because it'll be easier for me to see. Yeah. I'm allowed to do it right now. So let's go ahead and start going over it. We got a couple minutes. Shouldn't take a super long time. So again, we've done a lot of stuff with weights. And since you can do you can even do midpoint with weights. Remember, it's just like both weights are what? It's a midpoint, both weights would be what? One. You just make both weights one. And then you can do this. So you better know weights backwards and forward. Do them in your sleep. Because it'll solve every single problem that's going to be on that quiz except for the conceptual ones. So I circle, remember, once I write the weights, I circle. And then that tells me to do what? 5 times 1 is 5, plus 3 times 9 is 27, divided by the weights added together. So 8. So this is the same thing we did before. And I get 4. What's the 4 stand for? What's the 4? Yeah, that's going to be my x part of the coordinate. Because remember, I need an x and a y to put a point on a graph. So there's my x. Now, I do the exact same thing. I just do it with the y values. So there's the 5, the weight circled with the y value, the weight circled with the y value. 5 times 2 is 10, plus 3 times 6 is 18. I'll always have the same weights on the bottom when I do the y's, because the weights didn't change. Just now I'm using the y values. So 28 divided by 8 gives me 3.5 for my y. And we said, if I did it right, that better fall on the line. Girl, I do not like when people pack up early and they're not getting it. So if I go to 4, 3.5, sure enough, I fall right on the line. So if you fall right on the line when you go to put the point on the graph, you can be pretty confident. So there are videos that I posted where I went over a whole bunch of practice problems. I probably talked a little bit about